Let's quickly take a look at the law of segregation and independent assortment. Now, whenever you hear about the law of segregation and independent assortment, what comes to your mind? I guess it should be Gregor Mendel. Yes, the father of genetics. He did a great job in the study of genetics. Now, before I talk about the law of segregation and independent assortment, I would want you to know something very important. And that is every characteristics or every trait comes in pairs. Okay? Every characteristics or trait come in pair. Each member of that pair is called an allele. An allele. Each member of the pair is called an allele. Okay? Now, the pair, each of the member, they can be identical or unidentical. Now, when they are identical, they are called homozygous. When they are unidentical, they are called heterozygous. Now, this is what I mean. Let's assume we are talking about the characteristics of height. And let's use T to represent it. Now, remember, the alleles are two, making up a pair. So, you would either have the first allele and the second allele, or you have the first allele and the second allele. Now, what does this signify? This signifies a homozygous characteristics. That simply means that each of the alleles are identical. Looking at this stands for heterozygous, meaning that the characteristics are unidentical. They are different. Okay. Now, having known that, the law of segregation simply states that during the formation of gametes, the sperm and the egg, something very important happens. These two characteristics, these alleles, they don't enter into the gametes as pairs. They don't enter into the gametes as pairs. So when gametes are being produced, something happens. These pairs segregate. And what is segregation there? Segregation there simply means separation. So let's assume that let's assume that this is the man and this is the woman. Okay? Now during gamete formation, the man will produce the sperm, right? Now, this trait of height, what will happen here is that one of the allele will have to go into the sperm. The both of them cannot go into the sperm at the same time. They cannot be transferred to the gamete. And that is because segregation must occur. So segregation in this case is separation. Okay? So the man will either, there is a 50-50 chance that it will either be this allele or this allele. So any of the allele that enters, let's assume it is this first one. So this is this sperm. Okay. Now, let's assume they are already homozygous. So it will give the capital T. So there must always be a separation. That is just the law of segregation. The traits must separate. You can't have the full trait go into the sperm and the egg. There must be a division, and that division is what we call segregation of genes. So when they segregate, this come together, and they meet at this point, forming an individual with this trait. So as simple as that, that is what segregation is all about. Now let's move into independent assortment, the law of independent assortment. Now for the law of independent assortment, it just states that each characteristics behave on their own. No characteristics is influenced by another characteristics. And I'll give you an example. Now, in this case, we'd have to use two characteristics. So let's assume height, right? And color. Let's say yellow and white. So this stands for yellow, this stands for white, this stands for tall, this stands for short. Now, let's also do that for the corresponding organism. Now, what the law of dependent assortment says here is that whenever there is a segregation, whenever there's a transfer of gene, right? The gene for height does not influence the gene for color. That simply means that if this is being segregated, let's assume we have this segregates and gives this, okay, is a characteristics. This segregates gives this, and this segregates gives this. That's the characteristics, right? Now, this is an indication that the gene for height cannot influence the gene for color. Neither can the gene for color influence the gene for height. So, if this were not to be so, if this were not to be true, what will happen is that whenever you see a, a an organism that has this particular trait, their offspring will also have that particular trait. So in a case where we have characteristics influencing another characteristic, that's what you're going to have. But in this case, they assort independently. They segregate, they arrange themselves independently of the other. That means the gene for eye color does not affect or does not influence the gene for height. They stay on their lane. They are arranged properly. Okay, so because the man is tall and white here, does not mean that the offspring will be tall and white. Okay, so that's just the law of independent assortment. Okay, so this does not influence this does not influence this, they stay on their own. So this is just the law of segregation and independent assortment.